Hey there, everybody. I'm James Gagnon. I'm the Western Regional Sales Manager for Stiebel Eltron USA, and I'm here to talk about not just Stiebel Eltron and not just our WPL air-to-water heat pumps, but heat pumps overall. Before I get to that, who am I? What is Stiebel Eltron? Stiebel Eltron is a water heating and heating company founded in Germany 100 years ago this year. Still headquartered in Holzminden, Germany, privately held by the Stiebel family with manufacturing plants all over the world. 6,000 employees with around $1 billion in revenue for the last few years in a row. Historically speaking, we're a water heating company. Tankless electric water heaters are what we've been making for nearly 100 years. And in America, we have everything from the hand washing to the whole house and even commercial and industrial grade three-phase water heaters. But we've been active in other green tech, including solar thermal, as well as heat pump technology. Our company has been actively manufacturing various heat pumps since the 70s. We have the one of the largest and most modern heat pump manufacturing plants on the continent, and we continue to pioneer new and exciting heat pump, ventilation, and other types of green tech in Germany mostly, but manufacturing all across the globe. For the American and Canadian market, the water heaters and heat pumps are made in Germany. The air to water heat pump you'll see in the bottom right corner there is what is the WPL. It's a monoblock air to water heat pump. It's an outdoor installation unit. That sort of form and factor, Stiebel Eltron has been working with for over 10 years, and we've been on the US and Canadian markets for a little over a year now. But heat pumps are no new thing to Stiebel Eltron. Look at those cool haircuts and jackets, that old heat pump technology. We've been on the forefront of it for nearly 50 years. And we've been adding other types of heat pump companies to our portfolio, especially in Europe for the last bunch of years. Heat pumps are the future of water heating and heating, not just in America, not just in Canada, but around the world. If you've done any world traveling, you've seen all sorts of, especially probably air-to-air heat pumps. But if you're in Europe, probably a fair amount of air-to-water heat pumps doing all sorts of water heating and heating. America is catching on slowly but surely, but definitely catching on. You could say the heat pump market here in the States and in Canada, it's heating up. Various places for various reasons. Um, I won't get into the specifics, but there's certainly political climates, economic climates. There's a lot of clientele that are just getting savvier and savvier to trying to do the most energy efficient heating or water heating that they can. You guys would know better than probably even me if you're passive house enthusiasts. So heat pumps through like the I kind of think of it as the near magic of the refrigerant circuit, move heat around rather than producing heat with like a traditional, combustion of a hydrocarbon or heating up an electric resistance element. By moving heat around through the heat pump circuit, you have high efficiencies or coefficients of performance well above 1.0 for the coefficient of performance or an efficiency above 100%. And air to water heat pumps like our WPL monoblock cold climate heat pump can provide super high efficiency and performance for heating, water heating, and cooling, even when it's quite cold outside, with just one outdoor unit and a corresponding at least one, but could just be one indoor unit. So, heat pumps overall, a lot of you might already know, but the concept 101 is you are taking environmental energy, heat from the outside, or dissipating it to the outside in the terms of cooling. And you are doing that through your source of heat, be it the air, or in the case of a geothermal heat pump, the earth. There's water source heat pumps of all sorts. I'm talking mostly today about air source ones, but you take that sort of environmental energy and you take some electricity to run the heat pump, to run the fan, the condenser, the compressor, the evaporator, the sensors. And in doing so, you are using a small amount of electricity to run the refrigerant circuit and you are extracting, especially in the case of heat from the outdoors, be it the air, the earth, or water. And you are doing so with a notable ratio of small amount of input electricity, large amount of thermal energy output by harnessing the energy that is in the environment. So, borrowing from, as you might have heard, John Siegenthaler's slide here, he drawn out this basic sort of heat pump system here with the equations of above and below. You have the concept of taking heat from the outside. You are putting electrical power into the heat pump system, and you are going to, get a higher output temperature in a heating circuit. So the coefficient of performance, the COP, you're going to see all over the place in any sort of heat pump literature, is basically just a ratio of the useful heating or cooling provided um, to the work required. So in the equation here, you have your Q3 is like in the case of this raw equation, the actual heat temperature output. Q2 is the electrical power required to get there. Or another way of looking at it is the heat output in BTUs per hour, how we normally measure like the heating load of a home, divided by the electrical input in watts times by a constant to translate between BTUs and watts. So COPs of heat pumps range all over the place. I mean, if the outdoor air temperature is cold at like, let's just say the coldest ours can run at is -4 Fahrenheit. The efficiency of the system, even down at -4 Fahrenheit, even on when you're trying to do a very high outflow temperature, actually, I think this is a better way to show that. Here we have the COPs on the bottom, or rather the left. Higher COPs is more energy efficient. And over to the right on this graph, we have colder temperatures going down to the left. So a warmer day is off to the right, and a colder day is down on the bottom left, 0 degrees Fahrenheit here. The COPs of our particular heat pump, the 4-ton unit, the WPL 25, you got different lines for different output temperatures. So that's the um, Q3 in the equation there, like how hot of an output temperature you're trying to get. If you're trying to get very high outflow temperatures of up to 149 Fahrenheit or 65 C, it's less efficient. The heat pump has to work harder to take your outdoor air temperature, throw it through the heat pump refrigerant circuit, and then output really high outflow temperatures. But even doing so, on the coldest day of the year at 0 degrees Fahrenheit, let's just say, your coefficient of performance, your efficiency is darn near 200%. You get 2 watts of heat energy for every 1 watt of electrical energy you put in, even on a very, very cold day, even when you're working the unit very, very hard, trying to get that very high outflow temperature. If you were to do a lower outflow temperature, like the blue or the green lines, your COPs are higher at the various temperatures because the unit doesn't have to work quite as hard to bring your outdoor air temperature translated through the heat pump into your outflow temperatures. You use lower outflow temperatures for like in-floor heating than you would with, let's say, retrofit, trying to do radiators or certain types of air handlers or fan coils that might require higher outflow temperatures in order to do the proper ambient indoor temperatures. So here we have the various points at which you have benchmark temperatures. These are like internationally recognized benchmark temperatures. You have 47 Fahrenheit, a pretty cool day in California. The COP of our two respective units, well above 3. Darn near, 4.25 for COP or coefficient of performance on a 4-ton unit on a 47-degree day, doing like an outflow temperature of well above radiant at like 110. COPs in like the threes when it's 17 degrees Fahrenheit colder than pretty much any place in California. And then if you were at 5 Fahrenheit outdoor and doing a leaving water temperature of 110, this is a COP of 2.77 for the 4-ton unit. That's commonly cited as the cold climate efficiency benchmark, which is set by AHRI 550-590 standard. What is an air to water heat pump when you break it down? Like the other diagrams had shown, this one's in a little further detail. In heating mode, the heat pump would extract low temperature heat from the outside air and transfer it into a fluid stream, which is ideally water plus an antifreeze glycol combination in a part of the country where you could have freezing coupled with perhaps a power outage. You wouldn't want your unit to freeze while it was unable to circulate. If that were to occur, you'd certainly want some antifreeze or glycol in the lines in order to prevent like a, catastrophic heat pump freeze and break situation. So glycol plus water, low ratio in most parts of California. In some parts, you might be able to run this thing on straight water. The efficiencies are higher when you have a higher ratio of water to glycol. But in the heating sort of circuit, you are using a fan to move the outdoor air. If you're doing heating, it's going to be cool to cold outdoor air, but there is some heat in that air, even if it's cold outside. That heat will run along the evaporator coils and into the heat pump circuit. There's a compressor. In the case of ours, it is a Copeland-made inverter scroll compressor with an EVI technology. The inverter pretty much means that the heat pump can run at modulating capacities. It is not just on or off. It can modulate smoothly and surely, running as efficiently as possible. So here we have the heat pump circuit shown in the heating mode. Even if it's quite cold outside, by extracting some of the heat from that air, it exhausts even colder air out on the other side of the heat pump. But as the heat pump is sitting outdoors, it's not going to cool down your home any. It'll rather, in heating mode, heat your home. The water plus glycol, the hydronic heating fluid would then go into your home, and in the case of our units, into a buffer tank, which would then hydronically distribute your heat through the home. In cooling mode, the refrigerant cycle and the heat pump just reverses. You are taking, in the case of a cooling demand, warm outdoor air, running it through the heat pump along the evaporator, and you would certainly see hotter outdoor air expelled because the unit has not really like put cold into the home. It's rather, in the grand scheme of thermodynamics, extracting heat from the building. So cold fluid is running into the building and warmer fluid is coming back into the heat pump. So you are cooling the home hydronically into a buffer tank. You could do that through radiant cooling, or you could throw the buffer tank through a fan coil or air handler, and you could do cooling as such from there. Air source heat pumps, be they air-to-air systems that you might be more familiar with in the States, or air-to-water ones, air's always there. So even if it's, hot or cold, the air's there. There is heat in that air to dissipate in the cooling system or extract some heat for the heating system. You don't have to dig big holes for geothermal. You don't have to put, heat pumps into a big lake or anything for a water source in that regard. You just put your outdoor unit out there, 12 to 24 inches off of the chassis of the home, and you run the hydronics into the home, into like a buffer tank, and you're off to the races with hydronic heating or hot water, etc. When you do an outdoor heat pump installation, you're obviously not putting a heat pump into the home. It's an outdoor unit. You just need to put a buffer tank of some sort and some controls, some pumps into the home. You just need small holes to bring the hydronic fluid in and then out of the home to the buffer tank. And then with an outdoor monoblock air to water heat pump, all of the heat pump processes and refrigerants stay outdoors. So you don't need to bring the refrigerants all along the walls or into the home. You don't need to bring line sets around that could leaking refrigerant that is not usually pleasant for health or especially the global warming potential. So our air to water heat pumps come pre-charged from Europe, and you don't have to worry about running line sets all around. Our air to water heat pump must be partnered with a buffer tank of some sort. The unit on the right is our WPL or HSBC. It's like a combination tank, which has the controls, the buffer tank, and a domestic hot water tank all in one system. You don't have to partner it with one of ours, but if you were doing domestic hot water as well as heating and or cooling, you can do both of those or all three of those things with just one indoor unit. WPL, why do we call it that? The Germans sometimes have funny names for things. This one's very straightforward. WPL literally translates to warme Pumpe Lüfte, which German air source heat pump. The premium version is both a heating and a cooling unit, and our outdoor units come with a heating element, backup resistance element, standard in all of our units. We make two versions of the WPL for the US market. The WPL 15 A2W Premium is a 2-ton rated for cooling capacity unit with a 23K BTU per hour heating capacity. And the WPL 25 is a 4-ton unit with a 50K BTU per hour max capacity rating. So these units have a cooling and heating capacity that are very similar to one another. The back of the napkin is like each ton of capacity translates to around 12K BTU per hour of heating capacity. With one of our monoblock air to water heat pumps, it's not a split system. It's a monoblock. The heat pump and the heat pump processes and the refrigerant all stay outside. It's a self-contained pre-charged system from Europe as such. You're just putting glycol water combo into the home for like a buffer tank or hydronic heating system. These units do not require, as such, an HVAC technician to charge the system up or do the installation. A hydronics plumber is the ideal candidate to install these. More and more plumbers will likely be getting into hydronics in this country. There are certainly many qualified and established hydronics installers on the West Coast already. We're doing a lot of business in the greater Pacific Northwest with a lot of them. A single air-to-water heat pump, the outdoors unit, would be able to provide all hydronic heating, cooling, and domestic hot water needs with one outdoor unit. You can put two of them together if you had a especially large home, or if you wanted to do 6 in a combination, you could probably do a whole lot of water heating and heating for like a multifam situation. You can put up to 6 of our units together in one cascade pod on one controller with like a backup expansion controller. These units are very unique in that our WPL can put out an output temperature up to 149 Fahrenheit or 65 Celsius monovalently with just the heat pump running without the backup element necessary. And we are able to do such a high outflow temperature because we're utilizing EVI technology, which is enhanced vapor injection, sometimes known as intermediate injection. On the left, you see like the basic refrigerant cycle, condenser, compressor, and evaporator. EVI technology adds a subcooler or economizer and does some intermediate injection into the compressor to allow for even higher outflow temperatures at even colder outdoor temperatures and even higher heating capacities as such when it's quite cold outside. EVI technology is not signature to Stiebel Eltron alone, but we are quite good at utilizing it. Just a quick slide showing it expands the capacity of the unit in colder temperatures with higher outflow temperatures. If you are dealing with ambient outdoor air temperatures below -4 Fahrenheit, At that point, there is no more easy extractable environmental energy. Below -4 Fahrenheit, you would either need to use a backup resistance element within the unit, which is a separate circuit breaker to power it up, or you would need to think about a second heating source, perhaps propane based or something along those lines, in the case of a very, 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 very cold climate situation. Unit is engineered and manufactured in Germany with maximum decibel levels in the low 60s if you were to be at high full capacity, and a silent or night mode that can keep the maximum output decibel level at like 50 or 54. These numbers are measured right at the unit itself. When you get out a few feet away, those numbers drop dramatically. Furthermore, our unit runs very, very quietly with that inverter compressor and the overall inverter tech and the soundproofing they do. Some people have a hard time even telling if our unit is running. In order to wire up one of our air to water heat pumps, we would require a 20 amp circuit breaker for our 2-ton unit and or a 35 amp breaker for our 4-ton unit. And you need a 15 amp breaker. This is all 240-volt breakers. So you need two separate dedicated breakers to run the unit, one for the compressor and another for the controls. The controls would go both to the indoor unit and the outdoor unit with one single circuit breaker at very, very low amperage draw, just enough to run some controls, or in the case of our HSBC, in order to also run some pumps. These units that at the COPs that I've mentioned, these are third-party lab tested to the AHRI 550-590 standard. There is no current Energy Star category for air-to-water heat pumps in America. There will be soon. There was briefly, I think 4 or 5 years ago, an emerging technology section for the Energy Star category, and both our cooling efficiencies of 16 or so at an IPLV and our COPs of well above 2, even down at like 0 Fahrenheit, easily put us well above the requirements for that emerging technology category, and will certainly be um, will be a higher efficiency than necessary to meet whatever energy factor we need to be for the next Energy Star category that comes along. As I'd mentioned, you can use one of these units to do heating or cooling. Here is an example showing a cooling circuit. This is like a cooling in the floors as well as through some radiant panels. You could also throw the fluid after a buffer tank seen here in through a fan coil or air handler if you were looking to do more traditional cooling. Radiant cooling is a thing you can do and do a fair amount of it, especially where it is not too humid. This is a good introduction to our combination tank system. The HSBC 300 is a 270 liter or 70-gallon domestic hot water tank above and a 25 or 26-gallon 100-liter tank below. It's got the domestic hot water tank above a buffer tank with pumps and controls, diverter valve, and sensors all built into one indoor unit. So you're able to do one and one, done and done installation for water heating, and cooling. So here we see the outdoor heat pump on the bottom left going into the heat pump in the middle, or rather the HSBC in the middle. So you see here you have your pumps and your controls, your domestic indirect tank above, and then you have your buffer tank below. So with this sort of configuration, you would have your heating temperature in the buffer tank below, whether it's going into radiant floors at like 100 degrees, or you could keep that buffer tank all the way up to an attempted 149 Fahrenheit if you were trying to do some cast iron radiators, or you were doing a certain type of air handler that required very high outflow temperatures. The tank below is fully separate from the tank above. So the domestic hot water tank can be at 120, 125, 140, whatever you really want the domestic hot water tank to be at, while the bottom tank could be, cooler for whatever maybe you're doing just radiant floor heating. Hydronic heating is so gosh darn efficient if you can do it. I'll expound on that in a moment. But in this case, as well as for cooling season, if you used our HSBC, you could still use the same buffer tank below during cooling season. The buffer tank below can be down at as low as an attempted 44 Fahrenheit. That's the minimum outflow temperature that the air to water heat pump can produce. So 44 below, as low as if need be, cooling your home, while the top tank, if there was a domestic hot water demand during cooling season and the buffer tank was cooling, the heat pump would reverse. It has domestic hot water priority and would heat up the tank quite quickly, I may add, and then go back to cooling your buffer tank during the summertime. Here we have the integral or the components within. You have your two pumps, the controller, and diverter valve all built into the indoor unit. It's kind of like a big refrigerator. Ideally used for residential single family, but as is the case, if you were to use, up to 6 units going into like a buffer tank and an indirect for water heating, certainly could do some multifam as well. I know that they've already done this in Germany many, many times. The capacity of these units, very flat heating curve. Some people would say, like, oh, heat pumps can't work when it's cold out. Well, down to 5 Fahrenheit, we have a very flat heating curve. The heating curve blue lines stay within the 40 to 50K BTU heating capacity zone, well down to 5 Fahrenheit. It's only below like 3 or 4 Fahrenheit that the BTU heating capacity of our unit drops below 36K BTU per heating per hour. Cooling capacity rated at 95-degree outdoor air temperature. Here's how we see our 4-ton and our 2-ton cooling capacity. And we've already covered the COPs. You get higher COPs when it is warmer outside. So higher outdoor air temperature leads to higher COPs. Here we have in the highlighted zones the quick like naming of the units, like 50K BTU capacity or a 4-ton unit for the WPL 25 and the AHRI 550-590 standard. These efficiency ratings here, A stands for ambient outdoor air temperature. LWT stands for leaving water temperature. So the A5 LWT 110 is the cold climate efficiency standard that is sometimes talked about as like the quick one benchmark you're going to talk about. Colder than you'd ever really see anywhere in California, but even down at those very cold outdoor temperatures, we still have a COP darn near 3 and a COP of above 1.5 or 1.8 if you are, or 1.78 if you are down at -4 Fahrenheit and doing a high outflow leaving temperature of 149. This is what I meant by a flat heating curve. Even as it gets colder, the chart goes to the left, the heating curve stays very flat, well within this 40 to 50K BTU heating zone. It's only around like 4 Fahrenheit that the heating capacity of our unit really starts to drop. And the COPs, as I had mentioned earlier, very, trending left. Colder air temperatures lead to lower coefficients of performance. There's less easily extractable heat in the air when it's colder outside. The blue line, if you are doing hydronic heating is the most energy efficient way to heat. It is notably more effective means fluid of transferring heat rather than blowing air around. What you lose in ducts, what you have to do with the diameter, rather than just doing a small thin tube of hot fluid. Hydronic heating is the way to go if you can do it. And if you can't, you still can put the buffer tank hot fluid through an air handler or fan coil for heating or cooling. But if you can do hydronics, you do it at lower flow temperatures. The in-floor heating's typically trying to run at like 90 to 100. So you can run the heat pump at a lower outflow temperature, which keeps the coefficients of performance even higher. If you're running, trying to do a sizing for a home, we recommend a proper, heat loss load calc. Manual J is one of the ways to do it. This is just a quick case study of like Boston, which is notably colder than pretty much everywhere in California, but a 4-ton unit doing a house that had like a 32K heating design load. Here we have the ability for the unit to do all the way up to like 40K BTU per hour with a high outflow temperature, even down at -1 Fahrenheit. Anything below that, you need to use perhaps a backup element or a secondary heating source. This is the traditional look at the various outflow temperatures you would need for various heat emitters. In-floor heating in that 90 range to 100. Cast iron radiators, yeah, traditionally around 160 for a traditional boiler, but if you put 130 or 140 or even close to 150 through a cast iron radiator, as long as the radiators are of a good size and the home has seen some sort of renovations in the 100 to 80 years since those cast iron radiators were installed, you can do some serious heating even through like an older traditional radiator with an air to water heat pump. You don't have to use our controller. Rather, you don't have to use the HSBC in order to power our unit. You do need to use the controller, though, no matter what. It's built into the HSBC, but separate here. You can only use one outdoor unit with one indoor HSBC. You can use one of our controllers to power up to two outdoor units. Or if you use one of our controllers plus the expansion pack, you can use up to 6 WPLs in one cascade pod together. And this is what it would look like if you used just our controller. You'd have to figure out a buffer tank. We make a 25-gallon buffer tank. Here is an indirect tank. We make some of those as well. And then you'd have to figure out your own pumps and sensors otherwise. Totally possible. I mean, if you didn't even want to do domestic hot water, you could just do heating and or cooling with our outdoor unit, a buffer tank, and the controller. You can wall mount our units. You can put them onto a stand. You can even put them on a pad. But we'd recommend, typically, if you're going to be in an area where it can snow, we would typically want the unit installed on a pad of some sort. You can use like racks. Like we have racks here. That's an installation in Massachusetts. There's an installation in Washington. And then here in Seattle, this was an interesting case. You can see the HSBC looming in the background of this older home with these weird basement windows. That is an application retrofit where they put the unit and its fluids through the cast iron radiators. And it was able to keep this home, this older home, very hot and happy, even during a very notable cold snap that the Pacific Northwest saw earlier this February. So those cast iron radiators were looking for 130-degree water, easily met by the maximum outflow temperature of our unit of 149. At this point, it's just about, 50 on the hour. I'm going to cover one more slide or two and then pass it off to questions and answers times. Kim, I don't know if you've been looking at the questions. If you wanted to direct traffic there, I could also look at them. I think it's probably a good time for questions. Kim, want to see if there's anything you wanted to say or do?
Yeah, sure. So lots of questions in the chat. First we have Gary. Gary, did you want to unmute and ask?
Thank you. I'm my focus is on hot water more than anything else, for domestic use, not for space heating. And it looks like you have an external heat pump. You're showing us the units that sit outside, And based on what you've said, my question is this a cold climate? And the answer is yes, down to -4, if
Yes.
I listened carefully.
Yep. Without the
Um,
backup element kicking in whatsoever, unless absolutely necessary, the numbers and efficiencies and capacities are monovalent, just on the heat pump.
right. Related question. Do you have an integrated heat pump water heater? I thought I'd seen something, but I don't see it on the website looking today.
Yeah, we have a Accelera heat pump water heater. It's a 58 gallon or an 80 gallon heat pump water heater. Sure.
And that's based on the UEF method of test here in the US for its COPs and things, or its efficiency.
Yeah, but
Okay. I didn't
more of a
see it on
Europe.
the website today and I'm confused. I saw it a week ago and now I can't find it. So
It's
I
on
got
there.
lost.
It's under water heating or renewables. It's there.
Okay. I'll look again. Thank you.
You're welcome. What refrigerant is used in this heat pump? This is a 410A unit. To answer Oleg's question, defrost. It's an active defrost. That's a question from Dave. Feel free to unmute yourself, Dave, if you wanted to ask in further detail, but it's an active defrost. And it would switch circuit, in the winter, if it had to do a defrost, it would switch over and borrow some of the thermal mass of the buffer tank. That's one of the other reasons we mandate a buffer tank is a happy and healthy defrost cycle.
Great, thanks.
And what's the outlook of getting certified? Certified by whom exactly, Rebecca? There is no proper Energy Star certification category for this unit yet. There will be soon, and we'll be on it when there is.
That's my question is when is soon?
Take that up with ASHRAE. We're on the board.
I've asked them, I've gone to the government, I've gone to the energy efficiency person that actually handles this, and they can't give me any kind of date. So I was hoping you might have a better
I'm
sense
not
of
in
it.
those conversations. My colleague, the heat pump development lead, is. It should be soon. I imagine within the next year. I mean, heat pumps, especially air to water ones, are too efficient for them not to have a category. I know hydronics isn't as big here as it is in Europe, but the
Is
efficiencies
there a consortium of air to water heat pump companies that
there
are
is an
really
action
working with the
committee.
government to
There's a
get
there's a
the ASHRAE?
there is like an ASHRAE group. There is a heat pump action council that we joined recently. We're working on it.
Yeah, I mean, it's a huge impact on sales because people are not eligible for 25C until you get that.
Yeah, I don't know who has to certify it exactly. As
Well,
far as
the
I read,
government told me that they have to come up with their own certification, whatever standard for this, because they can't use the air-to-air ones.
Mhm.
So who knows? I don't know why they can't use the European standards, but
Yeah, I mean the COPs are there. It's pretty obvious. We're working on it. I assume like there'll be something along those lines, either especially from the state level as well. A notable slide I should hit is certain states are just doing it. You have Vermont, you have Massachusetts, big rebates from the states. British Columbia, I think New York is working on one. So there are already rebate plans in place for these, even as air to water heat pumps without having to like shove them in as an air to air unit. Like, no, there's an air to water category now, a qualified products list in many states and even the province of BC. And we're going to see more and more of that.
great.
And are we planning on bringing a new refrigerant? Yes, we have R454, if I'm not mistaken, already in production in Europe, as well as R290 units already in production in Europe. More details to come about when we'll be bringing those to America. But yeah, the conversation's already in place. We're aware of the need to go for a, low GWP refrigerant beyond just 410A, and we are already doing so quite notably in Europe. Those units are already in production. Even the super low GWP R290, that's already a thing. So yeah, it's R452B is what I believe we're planning on taking into the States. do we have an outdoor heat pump water heater? Yeah, this is it. It's a heat pump and for heating and for water heating. You can use it just for water heating if you'd like. Here's the recovery rate. It's very fast, but we do not have like a Sanco equivalent, like just water heating unit. This is the outdoor heat pump that can do heating, water heating, and cooling, and at super high efficiencies. It is not exactly what I would call a solo heat pump water heating device, but it certainly can be. In the case of this, this was kind of drawn up with the idea of it being for domestic hot water primarily or only. So yeah. What is the noise level? 60 to 66. Those are the two units for max outdoor decibel rating. 61 for, yes, good slide for, no, on the brochure itself, it says 61 and 66, and then 50 and 54 in the quiet mode. Christian had asked if you can purchase the Acceler in California. You sure can. Oh, John Snell answered that. Great, thank you.
Let me jump in here because I actually have one at my own house, running them here since 5-6 years. Very happy with the product. I tried to price them for another project, and I contacted Ferguson, and they said, got an email from them, provide a quote, cannot provide a quote for Stiebel Eltram item as it's not registered to be CEC compliant.
We sell these in California. I wonder
That
how
was a
long
response
we got
from
that.
Ferguson
How long
recently,
ago was
so,
that?
end of last year.
Oh, I think there wasn't a hiccup there. I think we've sorted that out.
Oh, okay, great.
Yeah. If you don't want to deal with Ferguson's going to stiff you, I mean, talk to the people at Pace. They can get it. A lot of people can get it. I'm looking at a retrofit. Is there a simple way to use the heat pump in conjunction? Yeah, you can. I'm not an air guy. I'm a water guy. Fan coil or air handler, the fluid in the buffer tank is cold or hot to a very high or very low number. So you could use an air handler off of the buffer tank, sure.
Okay, thank you. I think I missed that in the slide. You just passed through it, so I saw that you had air handler there in the comparison. So thank you.
You're welcome. Yeah, because we don't make air handlers, we don't make fan coils, we don't make panel radiators, but it's not rocket science. You take the hot fluid and you do what you need to do with it. Camille had asked if our hydronic sub has no idea how to purchase this system. Who do they contact? You would want to contact our sales rep agency, Mainline Sales. They are a great company. They got locations in Anaheim, they've in Sacramento. They have some of this in stock in Sacramento. So Pace can buy it. Any major plumbing wholesaler can acquire these units. We do not have any CO2 refrigerant products. We're not doing it. We're going to our low GWP refrigerant is R290. That's something that's already in production in Europe. Dave had asked, trying to replace an outdoor tankless gas-fired domestic, no room inside for a tank. Yeah, go with an electric tankless then. And then Rebecca had asked, how does it handle the shoulder season with evening heating? That would be a tough but you'd have to think about needing 2 tanks, or it would do the shoulder thing kind of weird. I don't know how. I think it's hard to do in the same day. I've not seen a good solution for that. It can do domestic hot water hot in the middle of summer. That buffer tank is fully separate from the domestic hot water tank, but that same buffer tank, that would be tough to do in a single day. I don't know the time.
James, could you we're up to the end, and I think some people are going to leave. I know you can stay, and anybody that wants to continue with the Q&A, we'll in about 3 minutes we'll be back to it. But if you could unshare so that I can do the closing.
Oh, sure.
I have a couple
No
of
problem.
a couple of things that I would like to show folks. So thank you for that. I'm opening here to the Passive House website, Passive House California website. And I have two things I want to show. If you go from the opening page, from the top page there, whoop, no, didn't mean to do it that way. And if you scroll down here, there is something called Implementing Passive House for Title 24. I'm going to click on this because it will open it up. And you could find that on your own. And what this is, it's about Climate Action California. We see Robert Hall is here today, but basically what they're working on is getting the legislation to accept or to let passive house standards be usable as an alternative to Title 24 for the energy efficiency, or for those parts where it is. So I would suggest that if you can, you can come to here. There's a fact sheet. There's some other information. It's on the website. I wanted to let you know that. The other thing I'd like to show you is here. If you go to the resources tab on the website and click on publications, we have just now published a Passive House California trifold brochure, and I'll click on more information to go to it and then link with the additional information that's on it, and let you know that the brochure, which is titled Future Ready Buildings for Comfort, Resilience, and Sustainability, each panel of the brochure it's a trifold. So when you come down here, if you would like to look at the trifold, these are the parts that are on the trifold. And if you want to look at a specific part and you want more information about it, one of them that came up that was kind of interesting, it connects to the something that's coming up in terms of getting the architect to move toward efficiency first design, which is coming up in a Passive House network thing that's coming on. So I wanted to share those with you, just let you know they're right there on the website for you. And then I want to come to the call to action, and we'll turn this into a slide now. The call to action for you, and it's not an unusual thing. We always have that. Do the best you can until you know better. Then you know better, do better. Supporting Passive House, we have a newsletter you can sign up for on the website. You could become a professional member, an individual professional member, an organization company member, sponsor, donor, or volunteer. We do all of those things. I'm going to click forward twice. PassiveHouseCal.org, by the way, is the website and where you can get to it. And I'm going to jump forward twice here to the next virtual community meeting will be the 18th of June, and it's Electrification and the Grid. It's by Southern California Edison, and they're here. Dave Entner, who is going to be the presenter, is here for this. And so finally, thank you all for attending. This is info@passivehousecal.org is how you can find get called back about things if you need anything to know on those. And now I'm going to stop share again so that you can pick up again, James. And if people want to stay around, we'll keep this open for as long as people have questions to answer. So thank you all for your time and attention.
Yeah, thank you so much, Jay and Kim, for hosting this. I really appreciate it. I've got more time and more slides if anybody had further questions or comments. I'm here for y'all if you want to talk about heat pumps some more.
Yeah, I'm sorry. I was going to say that, the typical condition that we find in Southern California is an 18-inch crawl space, an attic that has insulation on the ceiling joists, and a garage that has too much stuff in it. And so, what's the most efficient way within those parameters, in your opinion, to basically go from your gas-powered hot water heater and your 2-ton unit that's often sitting on somebody's roof?
If they're looking to do in Southern California, I mean, there's no way you can get around the buffer tank. You need to use a buffer tank with our unit. It could be a 25-gallon small buffer tank if they're not looking to do domestic hot water, or you do a second additional indirect tank for domestic hot water. But yeah, in small houses, you're going to have a hard time unless you have room for a tank.
Yeah, and that's the one that you were saying is about the size of a refrigerator. Is that correct?
Yes. So
Okay.
if you want to use our HSBC, it is like the size of a refrigerator. There it is.
Right.
Doesn't require any venting or anything, but it's a refrigerator. It's a small closet. Its dimensions are listed here. It is a 26 inch by 36 inch, 6 and change feet tall. If
Sure.
you had a like narrow basement in which you were trying to put it, you could take the bottom apart from the top and then reassemble it after you get it into the basement, but you can't run it separated. You need to combine the two pieces in order to run it.
Right. Well, okay. Well, thanks. Thank you.
You're welcome.
The unit is the decoupling from the tank and the outdoor unit is kind of interesting for the sound perspective, and that you don't need the volume if you have it in the garage or in the attic from the
Mhm.
accelerator units. How
Yes.
does your system compare? The first unit which comes to my head is the Sandon system. How
Sure.
does yours compare to it, or in terms of size, in terms of installation, in terms of cost, in terms of performance?
Yeah. So the Sandon unit is a CO2 based water heater unit. It is using CO2. It is an interesting product. It is a water heating unit. It pretty much has very little to zero heating capacity, and each of those individual outdoor units is, I think, around 13 to 15K BTU per hour. Our small one is 23K BTU per hour, and our 4-ton unit is like 50K BTU per hour. So 3 times as strong in an outdoor unit that's sure a little bit bigger, but it's still just one outdoor unit that can do, very high outflow temperatures for actual real heating and water heating and can do cooling. Our air to water heat pumps without CO2 can do cooling. The Sandon unit is pretty much just a water heating unit. Advantages of theirs, they already are using CO2 in regards to a low GWP refrigerant. That's cool, but CO2 refrigerant based heat pumps are also extremely highly pressurized and are they're not very serviceable. You can't easily service them. Like if something breaks on it, you're pretty much replacing the whole thing, as far as what I've been told by the people who work on these. Their unit has an advantage in that you don't need a buffer tank because you're just doing water straight out. So that's an advantage theirs has. If you're doing, I think, water heating, I don't think they really have like a buffer tank so much as a domestic tank. So they have some advantages depending upon what you're trying to do, but ours is far stronger and can do cooling and actual heating as well as domestic hot water heating.
Can you share a PDF or can you submit something for smaller application if you have something, or if it's on the website? I didn't see that on the website yet.
Smaller applications. How do you mean? Like the smaller of our 2 units, the 2-ton unit?
No, if you have a PDF brochure or the technical documents. I saw the
Oh yeah.
accelerators and the water heaters, but I did not see that unit. So it sounds like an interesting concept if you do
It's
heating and cooling and water heating in one unit, and that would be interesting to take a closer look.
Yeah, so our website features the WPL, but it features it. I'll go to there. Let's share that screen. It features it under heating rather than water heating, I think right now. Let's new share. Let's do there, there, and then we would go to heating. There we are. So under the heating, and then you scroll down past our wall heaters and our hydronic pre-modular panels. Boom. There we have the air to water heat pump and the various documents, installation manuals, including the brochure is pretty darn good. It has all the tech specs listed right here. Further tech specs are available on the website via the installation manual and even some of the slides. We even have a quick little YouTube video showing the unit in various ways. Yeah, a lot of the content from the presentation is here, including some nice stylish pictures of the unit itself, as well as dedicated pages to the controllers. The Germans, they do a good job. Heat pump manager, pretty much, for WPM, in the nomenclature here. Let's see. Any other questions? I think someone had asked where to find our Accelera heat pump water heater. It's under water heating. And there it is. Yeah. We have a 58 gallon and an 80 gallon. European design, very small backup heating element, mostly just all heat pump. See, is there any other slides I needed to hit? If I have y'all. Oh yeah, the connections. It's a very straightforward, just copper into like some John Guest fittings. That's your hydronic fluid. And then you have the electric panel right above. You wouldn't want to install it in a box. You want it to be able to breathe, but you could put it in like a corner, so to speak. You want there to be like sufficient clearance in front of it to breathe. You wouldn't want it to be on a roof without like a building wall or windbreak. And we don't want it installed within 1/3 of a mile of the ocean salt water. And we do have accessories that allow for a second heating circuit if that's something that interests folks. That way you could do like 2 different heating sources. You could have your buffer tank at 149 or 140 or maybe 120 to do like air handler or panel radiators. But then you could also have this HKM integral accessory allowing for a thermostatic mixing valve and a pump that would allow for perhaps a lower temp in the floors. If you had floor heating in one part of the home, but upstairs you had some panel radiators, one-stop shopping for easy zoning. And then for the electrical, you need the 2 breakers over here, the control breaker and the compressor breaker. The electric backup heating element, resistance-based, which is standard in the unit, is not mandatory for wiring. It would require a dedicated 30, or you could utilize half of its capacity and use a smaller breaker if you were so inclined. And the power consumption is listed here. It's pretty low kWs. Obviously, it's got super high coefficients of performance. When doing a hydronic system like this, you'd want to be sure to use air separators, fill the hydronic system from the bottom. Air is bad. Use the air separators appropriately. And here is a good electrical drawing. Here is your hydronic heat pump. On the left, the outdoor installation, you have your compressor breaker, and then you have your controls breaker going to both the outdoor unit as well as to the indoor controller, which in this case would be the entire HSBC with the controller built right in. And then that would also run the pumps within the HSBC off of this one low capacity 15 amp 240 volt breaker. And then here is the optional 30 amp breaker for the full jumpered over capacity of the domestic hot water based, resistance based backup element, which could do backup heating for both the domestic hot water demand as well as for the regular heating demand. And if you're looking to have a large house or a high heating demand, you could put 2 units on one controller. In this case, this is a buffer tank and then also an indirect tank for domestic hot water. In the case of using 2 units, you'd want to use 50 gallons of buffer tank capacity instead of just 25 gallons like you would for just one heat pump. And here are some of the other players on the market: Space Pack, Enertech, Chiltrix. We have for our 4-ton unit compared to the other like 4 or 5-ton units, We have the most efficient unit at that AW5 LW110, that cold climate efficiency benchmark. And then the capacity of our unit when it's quite cold outside remains very, very high. A lot of the other players are not able to get up to 149 Fahrenheit. A lot of them max out at like 130. And our heating curve is very flat. Even when it gets very cold outside, our red line stays very, very, very flat, while a 4-ton or 5-ton unit by somebody else starts at like a 5-ton, but drops off pretty quickly once it gets actually cold outside. And yeah, when we ran this unit and did like a 3-month test during the coldest months of the year in Massachusetts, this is 2 hours west of Boston in Hatfield, Massachusetts, where the company headquarters is for the American operations. We had a COP of 3.27, running pretty low supply temperatures in order to heat the floors in our warehouse. So there's a 50-gallon buffer tank. Here's the controller. There's a resol controller as well there. Certainly saved us money over gas. And here are some, pictures of some of the installations available that we have. We've installed a bunch of these. We're not an installation company, but I've been to some job sites. A lot of these units have been installed in the Pacific Northwest. A few have been installed in California. The Northeast is also our secondary hotspot, but the Pacific Northwest is where it's at. That's where a lot of these are happening. And I expect more in California soon, especially if California makes a rebate program for them. Massachusetts has, Vermont has, British Columbia has. And yeah, that's the full lineup of accessories pretty much there. The heat pumps, the wall mounting or floor mounting kit, the tank. If you don't want to use our tank, you could use our buffer tanks, or you could use anybody's buffer tank. If you're going to use our outdoor unit, though, you do need to use our controller, no matter what. If you wanted to have an indoor room thermostat, talk to the unit. We have a nice FET, which does have a humidity sensor built in, so that if you want to do radiant cooling, you can. You do need to use the FET as such, but if you did want it to be able to like tinker with your outdoor heat pump or the controls, and you didn't want to have to go into the indoor unit, wherever it is, the basement or the garage, you don't have to. Okay, and I've got some questions. Ooh, here we go. Can it be programmed to not run during peak hours? So is it demand responsive? We are working on that. There is no, how you say, like CTA port on this unit, but there are the abilities for us to use an accessory that would then have demand response from the grid. Otherwise, you can tell it when to run. There's a lot of capacity in this unit to schedule when it would run and when it would not. But for the grid demand response, it's an accessory that we are working on. IEQ and hydronic versus forced. How do air mixing and air filtration compare? Both systems would need whole house ventilation and filtration. Yeah, they probably would. Tom Phillips, I'm sorry. I don't have a good answer for that. I'm a water heater guy who's now a heat pump guy, but I know very little about air and air filtration. I know what I know, and that's something I don't know. Is the flow of the hydronic fluid to the heat pump to the buffer tank and back to can it work with a Nest? I mean, our controller needs to be installed. I think you can use a Nest or like a Tecmar. I know people have used some external thermostats with ours. But yeah, flow of hydronic fluid to the heat pump, to the buffer tank, and then back to the domestic. Yeah, I think that's how it goes. Good slide for that. Let's look at the HSBC one. It's like there's they call it a three-way valve, right? Diverter valve. And it's like two circuits within the HSBC, or it looks something like this. two different like pumps. Yeah, if anybody has any further questions, comments, I've run through all of my slides I needed to hit, and then some I didn't even need to, but I'm really happy I was able to with y'all. I appreciate the bunch of questions. I'm a sales manager of these products. I'd like to think of myself as a pretty decent technical salesman, but further questions could be answered in further detail by my heat pump development lead. He's based in Massachusetts, and we have a few other people in Massachusetts on the team. And then, we've been making these in Germany for a long time. Questions beyond him could go to Germany and come back.
Thank you, James. Maybe you want to put your email or your contact into the chat in case there's some follow-up questions. And because I took over, Kim had to leave, unfortunately, to another meeting. And so this way, everybody has your contact information and can get in touch with you to answer more questions. But thank you very much for the thorough presentation. And I think everybody learned something new today. And at least I got interested to look in a couple of other items of the Stiebel Eltron heat pumps.
Excellent. Hey, thank you for helping run the thing. Thank you for your questions and participation. And thanks for speaking highly of the Accelera heat pump water heater. Very happy you're doing well with it.
I like it. It works well. So I grew up with heat pump from Stiebel Eltron. My house, my parents' house in Germany had it. We had one hanging on the wall, a little electric one, and that's 50 years ago already. So it's an old company, and we had many of those. So, but thanks for supporting Passivhaus California. Thanks for answering the question in the overtime here. And maybe somebody else has another question. Otherwise, we can conclude. You have the contact information of James, and we see you around at the next community meeting next month.
Yeah, I've enjoyed sitting in on one or two otherwise. If it's a topic that I can relate to, I'm always happy to chime in. Furthermore, our website's pretty great. And the contact us page, there I am. So if you find the website, you can find me there. Email and phone. Furthermore, I put my email address into the chat. I'm happy to answer questions I can answer and forward the ones I cannot.
That's very good. So thank you very much. Thanks all for joining, and we see you in a month again.
Thank you. Have a great day, everybody.
Thanks, everyone.